And so welcome to our, was it 8th session now of Quick Pass. Glad to see everybody joining in. We'll give, folks a couple more minutes to come in. But we've stopped giving exercises on the material. And, last week we kind of introduced the last material or last new material. Now we're kind of going to go over some problem solving tips today. But before we do, I want to introduce Guillermo Aguilar, who is on the Platoon staff. He wanted to open the room to some questions. If y'all have any questions on the application process, I know there's some questions last week that I answered. And I just want to make sure everybody is super clear on the process because it's coming quick. The deadline is going to be January 22nd. So without further ado, I'll go ahead and give it to Guillermo.
Thank you so much, Aaron. Thank you for having me. How's it going, everyone? It's good to be here. I just wanted to come and answer, really just open up the floor for any questions you might have about the application or the live technical. Just so you know, I am the person that reads your application, watches your videos, gives you the live technical assessment, does all that stuff. So I thought it would be worthwhile for me to touch base as you guys were wrapping up your classes and answer any questions you might have. Go ahead, Casey.
Hi, Guillermo. Thanks for answering our questions. So the one I had that stuck out was after I submitted part 1 and then I got the email with the link, with the instructions, a link to part 2, the email said that we would be able to save our progress and return to CoderByte. But then when I clicked on the link to CoderByte, the first thing it says was I have to check a box that says, I understand that once I begin this assessment, I cannot leave and return to the assessment at a later time. So I was wondering if there's some reconciliation between those two guidances.
Okay, so you can come back to your coding challenge and start from where you left off. Now, there's a couple of aspects that go along with this. Some people decide to change computers. And if you started and did the first 5 challenges on one computer and then did the other 5 challenges on another computer, it's gonna process that as 2 completely different submissions. So that's not going to work. Also, if you started the coding challenges literally like a year ago, right? And you try to go back, chances are that that specific link has already filled up within CoderByte. So you're going to have to redo the challenges, right? If you cleared your cookies, you're also going to have to redo your challenges. So in theory, yes, you should be able to go back and start from where you left off. But if you cleared your cookies, you changed computers, or you waited too long and that specific assessment got full on CoderByte, all of that progress is lost and you need to restart it.
Okay, so is there like a save button or does each screen autosave?
No, so I don't really want to get into it, but it's actually saved in the cookies, your progress. Okay. But there is no save button. Like if you were to be halfway through a CoderByte challenge 6, right? Mm-hmm. You're like, oh crap, I gotta go. You close all your browser windows, but then you open the same one and nothing weird has happened to the link or anything, and open it a week later, all your code should still save.
Okay.
You should be in the exact same spot. Challenge 6.
Thank you. Thanks.
Mm-hmm. Any other questions, guys?
Hey, how you doing? Quick question.
Mm-hmm.
As far as the CoderByte challenges go, will we be able to perhaps go over similar challenges during Quick Pass that resemble, I guess, the coding challenges to see, to do it in a class setting kind of situation, like examples, I guess?
I think that's more of a question for Aaron. You're muted, but I think, yeah, you're muted.
So we're going to go over a lot more. So we still have a few more sessions of Quick Pass to go, and there's really not much more material. The next 2 lessons we're going to be going over are just techniques to help you problem solve, which I think will also help you tackle these challenges. And I'm going to have some examples. I'm going to show, similar things. And like I mentioned last week, I kind of wanted to take this class time, especially when we're working on challenges, looking at the application, to, as a class, maybe build like a lottery simulator and kind of go over all those techniques that you're going to use in, in these challenges. But these challenges are going to be your primary focus. So, using these problem solving techniques, if you have questions on how to do something, you identified in your application, you can ask something about that, like a portion, but I can't give you an answer to one of the problems. And I really don't want to
No,
work
of course not.
too similar, because I want to see how well you're using these individual components, these data types, and these the looping and those types of things, and putting those together on your own to come up with a solution. There's 100 different, 1,000 different solutions to these problems. And really, the biggest thing is, can you get it done? Did you get to the solution? Did you pass the test? That's the big piece. We're not all the way too worried about, how efficient is the code. We're going to look at that. We're still going to go over that actually today. But, we're just trying to see if you can get that computational thinking down.
Okay, thank you.
Mm-hmm.
Any other questions, guys? Oh, go ahead.
Yeah, I got a question for you. I appreciate being here. Could you explain what it looks like for the part of the exam where you watch us code, or the live assessment?
Yes, absolutely. So typically it's just 3 short coding challenges in roughly 50 minutes. Some people do 2 challenges in 15 minutes, in which case I just call it, be like, you're good. And I'll tell you right after you stop sharing your screen whether you pass or fail. The passing rate's actually really high. If you get 2 attempts at it, over 90%. And typically what we're assessing is we're only assessing one thing, and you're going to hear me say the following spiel. I'm going to go ahead and say it right now because I have it memorized. But when you jump on a Zoom with me, I'm going to say the following. I just have to go over a couple of things before we get started. Does that sound good? You're going to say something like yes, and then I'm going to say Platoon does these live technical assessments for 2 reasons. The first reason is to make sure you have a baseline understanding of programming fundamentals, and the second reason is we need to vet everyone that comes to our program. Make sure you didn't cheat on your application, and you can kind of somewhat know how to code before coming to our program. I'm going to say those exact words, and that's exactly what we're testing. We're just testing the following programming fundamentals, and I'll go ahead and say them right now, which is part of the reason why I came. We're going to test you on the following: loops, variable assignment and reassignment, manipulation of strings and arrays, key value pairs and dictionaries. That's it. That's the only thing you're going to be assessed on. So you'll most likely get 3 challenges, but it's possible that you only get 2 if you do it pretty quickly. And we're only testing that you didn't cheat on your application and you have the minimum, keyword here, minimum skills required to succeed in our program. We have great curriculum. We have great instructors. We don't need you to be pros, right? But we need you to have a little bit so we can get you across the finish line.
Awesome. Thank you so much.
Mm-hmm.
Yeah, I have a question. What do you consider to be cheating on the assessment or going through the course? Like, I know, like I look a lot of stuff up on Google and YouTube to kind of get me started on the exercises. Like, is that considered cheating?
So for the live assessment, you can't Google anything, right? I'm going to be looking at your Replit or looking at your VS Code, whatever text editor you decide to use. But you can lean on me for help, right? Like if your syntax is wrong, I'm going to be like, hey, look at line 7. What's wrong with line 7? Okay, what are you thinking of? Are you thinking of this method? And I'll go ahead and toss it to you, right? But I need to see that you have kind of the problem-solving skills that we're looking for, right? But as far as the assessment is concerned, you just lean on me. You can't actually search for anything.
Okay.
I have a quick question. What if you have like I've gone through the Code Academy Python course, and they have these cheat sheets. Let's say a cheat sheet on loops, for example. If I wanted to print that out and have it next to me, could I say, hey, this is what I'm
No
looking
cheat
at?
sheets.
No cheat sheets.
No cheat sheets of any kind.
Okay, all right.
So you're going to come to realize, and I've actually had some people get kind of grumpy in some of the technicals saying, hey, like the job, you look stuff up, right? Why can't we look stuff up here? Well, ultimately, when you get to your tech job, and many of you will, you'll get to that tech job, you already have like 100 tabs open, So you're really going to search how to do a for loop. Like that's the least of your problems. You have really big somewhat intractable problems that you deal at work that you can't really copy off Stack Overflow, because you're going to realize in software engineering, a lot of your problems are one of one, right? So things are similar, but they're never going to be identical because no two code bases are identical in almost anything. Even the way that you run things, the way you inject parameters into it, a lot of different things. So that's part of the rationale why we don't let anyone look it up. Again, we're testing for minimum. That's it.
Okay.
I have a quick question, Guillermo.
Mhm.
I think I'm peaking, right? And I'm figuring the assessment, the initial assessment, right? I'd like to take it on the 18th, and then the live assessment, I'd like to take it on the 22nd. Is that going to be okay?
What do you mean? What do you complete on the 18th?
On the 18th, I guess it's the first assessment, I guess, the X amount of questions.
Oh, part 2 of the application.
Yeah, part 2 of the application. Yeah.
Okay.
Yeah, because
So
I'm peaking, you know.
okay. So this is a really important reason of why I'm here. I want to encourage everyone to submit your application as soon as possible, because if you're short on something, right? If you're short on something, typically like 90+% of the time you get a courtesy email from me. And if you've applied to Platoon before, you might have gotten, if you applied a couple cohorts ago, you probably got an email from me, be like, hey, you're missing a YouTube video. Hey, your YouTube video, set it to unlisted, but because you have it set to private and I can't see it. Or you're short on quarter byte challenges. I can't tell you the minimum points that you need, but we're looking for X number of points achieved throughout the 12 challenges. That's why 10, that you complete 10 is highly recommended, because it's hard to get to across the minimum threshold without at least 10. So typically you get courtesy emails from me when there's a lot of time. You guys are on a very compressed time frame. So I would suggest that you try to finish the application as soon as you can and take your first crack at the live technical assessment. In theory, you should get 2, and we always give 2 shots, because I know sometimes people get nervous, and a lot of the time, I would argue most of the time, I'm the first person that ever sees you code, typically, one-on-one, not in a class setting. If you wait until the 22nd, you will only have 1 shot at it, just so you know.
Well,
that's actually a big reason why I'm here.
Oh, okay. So what if I take it on, I guess, the first assessment on the 17th, and then I can do one on the next day on the 18th or something, or Friday.
Or you could do the
19th.
17th and the 22nd. That would work.
That's exactly what I kind of mentioned earlier.
Okay,
that
yeah.
way, yeah, that way I can see like, okay, this is where, you know, I'm going bad. I can correct it.
So make sure you're not getting confused with part 2 of the application and the live technical assessments. They're completely different.
Absolutely. Right? I understand that.
You get 1 retake at the live technical assessment. That was I was saying. So you can't actually schedule your live technical assessment until your application is finished. If you try to schedule something with me and you haven't met all the check boxes, I'm going to cancel your live technical. And in the note, I'm going to say, hey, you're short on YouTube video. Hey, you're short on this.
Okay.
Does that make sense? I can't evaluate you in person until your application is complete. That's a non-negotiable for Platoon.
Yeah, I'm fine. It's all about the rules, man. We're all military here.
Mhm.
Okay, so I guess I just need to shoot you an email, and then you just give me like details, and then I'll just take from there, and I'll schedule everything.
So what will happen is when your application is complete, probably in the next couple of days, I'll go ahead and post a Calendly link to your guys' channel, and you can schedule it whenever, whatever time is available there. Typically, I'm pretty good with flexibility, and I try to pick a bunch of hours in the morning, at night, really late sometimes, because people are all over the world. So, well, we understand that. We work with military people all the time.
Perfect. Okay. Well, I appreciate it, man. Thank you.
For sure.
Thank you very much.
Guillermo, when we submit our part 2, will that automatically be sent to you for review? And then once you've reviewed it and give it the thumbs up, then we'll be able to schedule the live assessment. Is that?
So how it's going to work, you guys are going to have to work with us a little bit, because this is the first time this program is running. So once you submit part 2, go ahead and schedule your live technical right away.
Okay, and you'll put the link in the chat.
You. Yes.
Okay, so you'll put, I don't know the link yet, but you'll put it in the channel. Okay.
It will be on your Quick Pass Whiskey Slack channel. We will add it to the bookmarks. But yeah, once you finish part 2, right away schedule your technical assessment. If there's an issue, I will find you.
Okay. So we schedule a live assessment with the assumption that everything's okay with our part 2. And then if not, okay, yeah.
Yes, and you do that for 2 reasons. One, to make sure that you get a time that works for you. And it happens kind of a lot where it'll be something really small. like you didn't set your YouTube video to unlisted and it's private. So I'd be like, hey, you need to update your YouTube link. And there's no reason for me to cancel your live technical assessment, right? You're gonna get back to me in like a day or something. You're gonna set it to unlisted. I'm gonna watch your video. You're gonna be good to go. You know?
Okay, great. Thank you.
I don't know if this has been answered, but for the part 2 assessment, we only have one shot at that, correct?
Wait, part 2, are you talking about part 2 of the application or the live technical assessment?
The coder bite assessment.
No, you have unlimited. You can do it unlimited number of times. I just see the final score. That's
wow.
it. If you tried it once, cool. If you tried it 100 times, I just see the final score.
Oh, okay, cool.
Mhm.
Thank you.
So what ends up happening?
Was there a passing score?
There is a passing score, but unfortunately, I can't share that with you per
Okay.
our founder. Yeah. So you can't really talk about so I know Aaron touched upon it, but that's frowned upon. Don't like share your answers to our application process. It's one of the only things in Code Platoon we guard pretty tightly. And if you've been in the intro to coding challenge, sometimes people will try to post about the application and people will get on them. Hey, we can't help you with that. Any other questions, guys?
Yeah, I have a question about the part 2 assessment. I guess the coder bite challenges. So if I'm going through those and I have questions or problems on something, so we're not allowed to ask any questions. Like you can't ask in the chat anything like how to solve a problem or anything like that.
We can't share any of that, and that's been a rule ever since I got here years ago. I don't know, Aaron, was that a rule when you were here, when you went through?
What was the question? Sorry, I was answering it.
You can't ask questions about the application challenges.
To the group right here, or
Yeah, to anyone.
Yeah, no, yeah, we want to keep that, integrity in that piece because it's, it's such a, I mean, again, you only listed 4 skills really that you would need to pass this challenge, and those skills have been covered basically already by Quick Pass. And it kind of goes back to that, again, we're not looking for you to be an expert in anything, but we want to see you be able to, just like in a foreign language, right? Identify some nouns in Spanish, some verbs in Spanish, identify, a simple sentence in Spanish, those things. And that's really it. Like, it's almost the same kind of thing. You can't really, you have to just know that material without having to look it up. And so there is some memorization in there, learning in that learning process, but it really is not much. And then, once you're in Code Platoon, then you have some resources available, as you learn more material. But this is the first starting point. Any other questions?
Yeah, I have a question. Could you name this for Guillermo? Could you name what you will be testing us in? Like you said, manipulation of strings and arrays, and what else?
Yeah, just the 4 things. I'll go ahead and name again. Loops, variable assignment, reassignment, manipulation of strings and arrays, and then key value pairs and dictionaries. Just those 4 things. Those to us are the foundations of programming, really. And you haven't got to this point in your career, but when you get a little bit more experience, you're going to realize that all coding challenges in every language can be solved with the same 4 or 5 things. You don't need any fancy built-in methods, any regex. You don't actually need any of that stuff, right? You can do it with the same 4 or 5 things.
Okay, thank you.
And that's what we're testing.
Okay.
Sorry, Guillermo, I gotta ask you to repeat those 4 things one more time. I got first 2.
Sure
I didn't
thing.
get the down.
No worries. I do it all the time. So we test you on loops, variable assignment and reassignment, manipulation of strings and arrays, and key value pairs and dictionaries, or objects in JavaScript, same thing.
Okay, thank you.
All right, last call. Any questions? Oh,
Someone just asked, will this whole portion be on YouTube tomorrow?
yes, yeah, I've been recording this portion so you can reference it. So you'll have that. And then Tim, anything in particular you should practice? I mean, practice your assessment, your part 2, practice the problems we gave you at the beginning of this. You'll see some more in my lecture today. We're going to go over some stuff, so you'll be able to practice with that. We'll have all that recorded. So
just so for clarification, we need to have part 2 done before we can schedule our live coding assessment.
Yes.
And when is the end dates for that?
So the hard deadline that I have is end of day January 22nd, right? So if you have an incomplete application or you haven't passed your technical, you're going to be dropped simply because our deadline is so tight. So the application must be done before then and the live technical before then. Hard deadline, January 22nd. The earlier, the better. And that's the reason why I'm here today. Just to encourage you to try to get ahead of it. Because that part 2 takes longer than you would think. When I applied, it took me like a week.
Yeah, I'm solving it right now. I'm trying to get it done, but I keep getting stuck. So
Yep. Super normal.
Yep. Yeah, it took me a few weeks because I was still in the military working and I was doing it on the job. So it took me probably a month to do mine. So
yeah, it took me a week without working. So that's about the same. I was unemployed at the time.
for scholarships, when do you guys want us to, like, is it still 22nd and we can still get scholarships?
Contact Tish on Slack or tish@codeplatoon.org. She will have a better idea with that. Here's a hot tip for you. Prepare like you're coming to whiskey and just assume you're going to get the scholarship. I've had people, and this has happened a couple of times, where they're so worried about getting the scholarship or not getting it, it like distracts them from the process. And then they show up to the technical and they don't know how to do it poorly. Can't let you in if that's the case. So your main focus should be, hey, prepare, assume you're going to get it, and then you can figure that out later. That's the best advice I can give you. Yeah, you're welcome, Athena. Great name, by the way.
Goddess of wisdom.
Yeah, we need more Greek goddess names. That's funny. Good sense of humor, too. Any other questions, guys? I don't want to take up any more of your time, but I'm here. Any last minute questions before I dip out?
all right, we're good.
All right. Thank you so much, guys. Last thing I'll leave you to, well, 2 things. One, Aaron, thank you so much for having me. Best of luck, everyone. And really the best piece of advice that I have, don't underestimate part 2. That's going to be the hardest part.
Perfect. Thanks, Guillermo.
You're welcome. Take it easy, guys. Thank you.
All right. Well, just to echo, his words, and, don't be afraid to post questions in our channel. He is also in our channel, so you can post questions there if you need to. You can always just tag him and he'll be able to see it and can answer it. So if you missed your question and it's not really, it wasn't covered on the YouTube, when you go look back at it, you can still ask questions in Slack. We have it available. Correct. No questions related to the coding challenges other than procedural stuff or stuff like that, but no questions on the content of them because, we want to make sure those are individual effort. But, I think, with this course, we've given you enough tools in your toolbox to solve these challenges. And again, he recommended you submit at least 10, right? He didn't say do all of them. If you can't do one of them, you could still pass. You can still have enough points to pass. We can't tell you how many points that is. We can't tell you that cutoff, that standard, but do your best on the application. And, it's still a pretty high acceptance rate. So That's what we're looking for. We're seeing that application and getting to that minimum standard. I'll get those 4 items again in writing because I can't remember off the top of my head right now, but he has them memorized. So I'll put those in the Slack channel as well. Any last minute questions for me before we move into the actual lesson? The lesson itself is going to be, it's nothing structured as far as new material. It's just gonna kind of go over some ways to think like a software engineer, ways to, you know, tackle problems that you have. And I think this could be applicable to the coding challenges you have now. And with it, I have some examples that I've found online that, you know, we can go over and take a look at, and go over some of these tools, you know, some of these methods. And so it should be a pretty quick lesson. But without further ado, let's go ahead and just dive in. So let me start sharing my screen. Share. Great. So we're going to go over some problem-solving strategies for Python developers. And, you know, a lot of these things we're going to go over are really conceptual. They're not going to be anything, you know, set in stone. It's really more tips and tricks to help you tackle the problems that you run into, that you could run into as a developer. And then, of course, what you're already running into on some of the application challenges and some of the challenges you've seen in the first couple weeks of this course. And so it's just kind of a way to formalize the thinking process and maybe get you to look at problems a different way or try different methodologies. And that's really what this is. Because software development is nothing but problem solving. You know, how can I get this content to, you know, a web application? How can I handle, people, several people logging in? How can I handle their organizing that data? How can I keep my application safe from cyber attacks? And it's not just software engineering, it's, cybersecurity or DevOps or any other discipline in tech. There's all sorts of problems that are solved, problems that, the general public faces that we want to solve for them. And then, of course, the problems that we have building that solution, and the problems all drill down to the very basic components of, hey, what data type do I have? How can I manipulate this? That it all goes down to those things. Just like Guillermo said, with the, all the problem solving we have, it breaks down those four things roughly. You don't need fancy libraries. You can break it down to those core components. And that's the challenge of learning this trade. I've always equated, software engineers, in this field as like modern day, like welders, even though we still need welders. Can you do a job? Can you solve these problems? Can you make that nice bead? Does your code look good? Does it make sense? It's the same thing. So it's a trade, almost a trade's job. It's just a little more technical, and there's a lot more technical stuff in it. So so with that, we talk about machine learning models or, data analysis tools, problems that require those creative solutions. That's what you're getting into. How can I create those solutions? And so we have some techniques that we've identified that will help you kind of think about problems that way. So so the first one, when you're looking at a problem, you just want to make sure you understand it, and with these coding challenges, that's pretty easy because they kind of give you the problem, right? They're like, hey, you have this, list, take all multiples, of 3 out of this list, or with the FizzBuzz problem that you've already seen, right? Take this, this number, these incoming numbers, and then change them to FizzBuzz or FizzBuzz based on how they can go into, divisible by 3 or 5 or 3 and 5. And so when you think about that, if you already have a problem statement, just make sure you understand it. look at the input, output, and expected behavior. When we talked about functions, right? We have a function, we define it, and then we have a we have a parameter. That's going to be your input to your function. And you gotta think about, okay, what is that input, and then what is my function going to be outputting? What's the behavior with that? If there's anything that's ambiguous, if you're not quite clear on what is actually being input in there, then maybe you have to think about how you're going to make sure that the data coming in is going to be a certain type. The constraints of the problem. And then you can always, whiteboard these problems, create an example. In Agile programming, they consider like personas. So they have like, I have this typical user, of this dog sitting website is, we have our, large breed dog customer, and they typically go for this and this service, and then we have our small dog customers who do this. And so you have examples and use cases for your application, if you will, and you can come up with strategies to make sure they have the right customer experience whenever they're using your application that you're building. So constraints. So, we have, our most valuable resource, the constraints on time, memory. So how memory intensive is your application? All the tools, all the functions combined, how do they use the memory of your computer? I have a pretty good example of that actually with one of my recent projects, and I can share that. Special requirements or edge cases, if you're looking at, allowing anybody of all ages into your application, well, what's the maximum age that you want to allow someone to come to your app? What age should you set as the maximum age or the minimum age? What about, if someone, puts in a negative number? That kind of goes into user entry and problems in that, but you have those special requirements. And then the problems, context, and potential real world impact. If you're handling credit card data, then you have to think about security, and you're handling financial information. So those are things to think about when you're developing your problem analysis and you're just writing it down. Any questions on those subjects? So the example I had for my machine learning problem is I'm taking this algorithm that actually has several models in one. So it's an ensemble model, and I have to train it on a bunch of data, and it's like 50 gigabytes of data, and it has to save image information for all these images while running on my laptop. I have 64 gigabytes of RAM and work laptop. And I found out pretty quickly that I can't just run all 7 training loops on that data because it runs out of memory. I can't, my GPU can't handle it, my CPU can't handle it. So I had to think of a way to maybe run them one at a time, and then have Python's garbage collection get rid of the previous training loops to free up memory while I'm running these other ones, but then also like save this checkpoint file somewhere on my hard drive, so I can then have it saved for the predictions piece. That was a real world problem. I had never run into anything like that before. I had never ever used all of my RAM on a higher end laptop like that before. And you wouldn't with the problems you're facing now, but you will eventually, and you'll have to think about ways to tackle that. So with part 2, we have decomposition. So we want to break down our complex problems. You want to take those big problems and turn them into smaller problems that you can tackle. And I think I have, let me see if I can find a good example of that. Well, I guess we can kind of look at, what I wanted to do with everybody, and that's a lottery simulator, right? So, you know, I want to build, you know, with you guys a lottery simulator, something that simulates the Powerball that will, you know, give us some numbers, and then, you know, you have a ticket and you want to, you know, check to see if you're a winner. And you know, there's other, you know, goals you can have with that, you know, track how much money you spent over how many drawings, and, you know, compare the money you've spent or money you've had and how much money you've spent or how long it's taken you to lose or win so much money. We can go on and on with this problem. But if we take a look at this problem here, like build a lottery simulator, okay, how am I going to approach doing that? What are the components of that, you know, problem? You know, what pieces of a lottery do I need to worry about coding, right? Well, we have, you know, what does the lottery consist of? Well, it consists of a drawing, and it consists of a ticket, and it consists of money spent on that ticket. And so, you know, how can I solve the problem of the ticket? You know, how can I code that ticket into something that's real? What data type can I use to store that ticket? Can I use, you know, a list, or can I use a dictionary? And so when you're looking at these problems, you see I'm just breaking it down to smaller pieces. I have my, you know, my drawing, and I have my, you know, user who's spending money. I have the money that I'm tracking. I have my ticket. Okay, so well, how can I you know, code that ticket? You know, well, I can use a list. Okay, maybe that's a good, and you can start whiteboarding these. And so just to introduce it, this is kind of what I've, you know, come up with here is, you know, a Powerball simulator. The program should generate a static user's ticket based on a pseudo-random number generator. Ask the user how many times they want to play, and based on that information, execute the desired number of drawings. And the program should tally how many times the player hit a winning drawing. It should also print out when the user hits a jackpot. Okay, that should be a pretty simple, like, minimum viable product. That's what MVP means. You'll learn that, you know, in Agile speak. That's something we could probably do in this class, you know, together, you know, getting suggestions. And it will involve all sorts of data types. It'll involve messing with strings, you know, messing with lists, manipulating the data. I think it's a really good exercise. So breaking those problems down. And so that's kind of how I, you know, just talking about it, that's what I did here. I divide the complex problem to smaller, more manageable parts. We can write a function to make a ticket. We can write a function to run a drawing. We can probably reuse how to generate, you know, random numbers. And third, we want to prioritize the subproblems and kind of plan our approach. So, like, what could I work on first? Well, I could work on, you know, making a ticket, because, you know, that's you can't have a lottery without a ticket. You can't have a lottery without a drawing. So maybe work on those two first and see how we can get that to work. Any questions on that so far? Is this kind of you know, shedding some light on the problem solving that you could run into? This isn't something that's learned, you know, overnight. It's something you want to go back and reference, but it's a way of thinking that can, you know, really help you do your job if you get into coding. So, any questions so far? Practice, yes, Tim, lots of practice. And hopefully that's what you've been doing in these off days between classes. If you see we're pretty attentive to until your eyes bleed, that's good. Until your fingers bleed, you know, lots of coding. Yeah, if you noticed in the chat, we've been pretty active. You know, I've seen some questions come in. I didn't get to one of the questions today because I was busy, but you know, Augie asked some questions, you know, and then Francisco came on and started answering, and then Mike Zura popped in as well. So, you know, if you still have questions, please ask them in the chat. Also, if you didn't see the message from Nick Smith, he wanted to ask everybody kind of where you're at. So, you know, with number one, are you still participating? Are you actively working on your coding challenges? Have you already submitted step 2? Do we have any number 3s in there? And 4, have you scheduled or completed a live technical assessment? I would imagine a lot of people will be, you know, putting number 4s out there if they've already completed it and got accepted. But I mean, you can still attend. So if you get accepted, you've done it early, you know, you can still attend and get some good nuggets. I see some numbers going in there now, so that's good. Moving on to the more of the decomposition piece, you know, you want to identify your relevant data and processes. So if you're thinking about like this lottery simulator, you know, what data am I going to need? You're not going to need any data because you'll be generating all of your script, but you know, you'll want to save some data. You know, you'll want to, you know, save maybe like a starting money amount, if you will, to, you know, to track how much you can be spending. And then you can also sketch a plan of how those subproblems interact. You can also visualize your problem structure. In this case, I don't know if a drawing is definitely needed, you know, but you could always write out your, you know, pseudocode of each function. You could do that. So any questions on these two topics, kind of understanding the problem or decomposition? Let me see if I have one of these. Give me a second. Clear all these outputs. Oh, nice. Yeah, it's gonna be good. I think, you know, kind of going over as a group how we're going to code that together will be pretty awesome because it can kind of show how we can break these problems down. I will talk about this last one here, this algorithm design. Again, this is going to be a really quick overview of these problems. I think more of the you know, applying these in practice will help, you know, hammer these home for you. But with your algorithm design, you want to make sure you select the appropriate data structures, right? And so what are the different data structures that we have in Python? And we can talk about it in terms of collections. So we have tuples, yep, dictionaries, strings, dictionaries, sets, lists. So you have all these types. And then when you think about them, you're like, okay, well, what's in the attributes of these types? We have our sets, which are our sets and strings. What are some attributes about those data types, those data collection types? Tuples are immutable, strings are immutable. Are sets immutable? Do we know if sets are mutable? Or yep, they are mutable. You can change sets. You typically can't change the items though in a set without totally redefining it, because the keys of a dictionary and the items in a set need to be the immutable data type. Yep. So dictionaries are mutable. Lists are mutable, and you know you're going to be using lists a lot. Like list will probably be your go-to on a lot of problems. If you've already have seen that with some challenges, lists are pretty nice. They're a good way to collect something and just hold it. You know, what I recommend when you're kind of tackling a problem, you know, you have an input and you have to write a function that gives you an output, right? Well, you can like set up like a list as like a bin to store things that you need as you're doing your data filtering. You know, I was guilty of making just a bunch of different like variables that had different lists. and I would keep track of those as I was building my problem. It wasn't the most efficient, but it was how I learned, how I was able to see my data change from one state to another as I was going through building my algorithm. And so, yeah, choosing the right data structures to represent your problem components is a good skill to have, you know, and you're not going to be perfect at it, but it's also pretty forgiving. You know, if you're thinking about, you know, storing something in a list, you have methods to use to get the data out. It may involve extra for loop or something to go over your data and find it again, but you could, or you can use a dictionary that has key value pairs to kind of find things quicker. There are trade-offs with both, you know, with lists. Typically, when you need to go back and reference a list and find something, you're going to have to loop through that list somehow. That's a trade-off. That's an efficiency trade-off. If you're gonna have to do, you know, several loops to find something.
Hey, Aaron, real quick.
Yeah.
Could you just to further clarify, a list is ordered, like it's sequential, and a set is not?
So a list is ordered as in when it's made or when things are being appended to it or something, right? It's going to maintain that order if you reference it later. It may not be in order, so it may not be, you know, sorted from lowest to highest or highest to lowest. There are methods to do that, you know, to sort a list, but
Right.
yeah, lists don't necessarily have an order when you think of like something alphabetical, but they do have order as in whatever you defined it as initially, it's going to keep that order.
And so I know you can order a list in numerical or alphabetical order. Can you do that to a set also?
Well, sets are unordered data structures, and what that means is if you were to like take a list, right, of and I can show this here. So if you have a list, so it's my list equals, and I'm going to say,
Because that's what makes it a set, is it's not able to be ordered that way, right?
right. So if I were to take, you know, my set equals set my list and then print it, or just do that, right? So like I can ask you, well, which 5 is that? Is it this one, or this one? Like you don't know. It's a unique value. They're all the same. So you don't know which one it is. So that in that essence, it's unordered. Like you really don't know. So does that make sense?
Got it. Okay. Yeah, thank you.
Yep.
Oh, real quick, just to add to that, could you explain why the set is quicker to reference than the list? If so, a list is you have to go through it, a set it can find it easier.
Well, I mean, with like a set, you're you know, you can find things because everything is unique. So with a list, you may have, you know, the same, like some of the same things in there. So it's really like not necessarily quicker, it's just a different way of you know, presenting data and then ways to grab it. So in this case, like if I want to pull all the even numbers out of this list, I'm gonna have to iterate over the list. So I'm gonna have to look at every item list and see if it's, you know, an even number and then pull it out. There's no other way around that, right? For like a dictionary, you know, you don't have to loop through a dictionary if you have a key to a certain value. So, but you still can loop over dictionaries if you need to loop over the keys for something or the values. So,
Okay, thank you.
yeah, it's really just, you know, when you're thinking about how you're going to, you know, go into a data structure, you know, it all depends on the context of how you're looking for the data too. So, the simplest way is always to loop over it, and you'll see. And you know, at this stage right now, you know, being able to build a loop and run through it. Of course, that's one of the 4 things he mentioned. You need to know how to do that because you need to understand how computers work. A computer can't just look at something and like your eyes and find something really quickly. Like you don't necessarily go in order with your eye. A computer has to do things very procedurally and, look at things. So, yeah, so that's kind of the difference between a set and a list really is that, a set is unordered. So. This next portion here, creating algorithms to solve, subproblems, that one, you're going to want to design an algorithm for each of those subproblems. And the best way to do it is kind of really pseudocode it or write it out. If you're a drawer, you can draw a flow chart. You can use pseudocode, which is awesome. Pseudocode is just nothing more than writing quick sentences, that states like I have a variable named this, and then I want to take this variable and put it into a list, or I want to take this list is my variable and I want to loop over this list. And then when you write out like what you want to do in just plain English in little comments in your code, then you can get to writing Python code afterwards. Always recommend doing that at least once or twice. I'm not a write down pseudocode kind of developer. I've never really been that way. I've been more like I like to mentally think about it and then kind of put code down as I think about it. But typically doing the pseudocode, especially if you use it more and more, it can be faster. So. So let's take some of these three concepts here, and let's try and work on a problem here. So in this problem, we have given a list of numbers, return a list of even numbers doubled and odd numbers halved. So, if we want to think about that problem in general, right? So it says, given a list of numbers, we know, like, we can look at this problem and kind of break it down, right? We have to write a function that takes in numbers, any list, any length list. So it can be any length, and it's going to have some numbers in it. And when we kind of think about some of these things, right? So is there any ambiguity to that? Given a list of numbers, well, maybe there is some ambiguity in that. Like, is it integers? Is it floats? Is it both? We have to think about that. Like, am I going to have to worry about that? Dealing with a float. And it says return the list of even numbers doubled and odd numbers halved. Okay, so like, how do I determine if a float is odd or even? If it's can I divide it into two parts evenly? Do I have to think about that? What about negative numbers? What about 0? What about, how am I going to do that? And so those are the things you want to think about when you're breaking down the problem and you're given this here. You'll see a lot of the coding challenges too online. They'll say assume everything coming in as a string, and that they kind of take out that ambiguity. But as a developer, you want to almost always think about that stuff. Like, I'm getting a list of numbers, but what if I get a list with strings in it? What do I do? How do I handle that? Because you could actually run into that problem. And there's a big problem with that with when you have user data entry. So if you have an application that has someone type their age, right? So it's a free text field and they can type their age. How many variants of age are you going to get? What if somebody, you have your age, right? Somebody could put in that, right? But they could also put in that 80. Now 80 is a string. How do you handle that? Can you handle it on the front end where it'll, color red and say, hey, it must be a number, like an actual number, you know. What if, you know, older than my sister, my age, right? You know, you can get anything. And what if they have a typo? So what if they're trying to type in, you know, 15, but they're like that, and they send it in, they submit it. Like, there's nobody who's 156 years old. Like, you should be handling that kind of error. So you have to think about that too. Like, all this stuff coming in, you know, that's something to think about. So in this case, you know, given a list of numbers, it's going to be a list of, you know, integers in our case, right? So, you know, what for output, like, what do I need to put out? Like, do I need to make it a float initially, like right off the bat, or does it need to be an integer? You know, how can I do that? And so, you know, if you think about, you know, dividing a number by 2 and it's an odd number, so odd numbers are halved, right? You're going to want to return floats because you can't return integers. So how can we solve this? Let's solve this as a class. What can we do? What do we need to do first, you know, with this incoming list of numbers? Because when we call this function, we're going to get a list, right? So this is our example list. What do we need to do first? We can just pseudocode this out, right?
My first thought would be to do like an if else statement, and then for the if I modulo 2 and numlist equals 0, you'd want to double that, and then if else you'd want to does not, like, modulo 2 does not equal 0. That would make it odd, and then you'd want to have that, but then you'd have to loop over it, and I don't know if you'd loop over it before or after.
Okay, so like here, we're like, okay, well, if number in list modulo 2 equals 0 means it's even. Okay, we know that. Good. Like, we broke that down. And then otherwise, oops, I need to do otherwise, it's odd. Okay. And then you mentioned something about a loop as well.
Well, since it's a list, you're gonna have to loop over in order to get every single value. So,
Okay, so we need to do that.
Would you-
We need to do that first or
you-
last?
I think first.
Okay, so
Would you not need to do that if you did list comprehension? You
well,
wouldn't need
list-
a loop?
okay, list comprehension is kind of, you know, already a loop, if you will, right? So it's a form of a loop.
I see, yeah, okay.
Yeah, I mean, we could do that too. We could totally do that if we wanted to, right? So maybe so build a loop, and then we can say, you know, list comprehension. I think list comprehension right now at this level is pretty advanced. But I mean, we could still look at the solution. But let's try and do a traditional loop, right? So what kind of loop? So let's break it down any further. What kind of loop do we need? You know, do we need a while loop?
For loop, because you could do for whatever the variable would be in range length of num to go over, I guess, right? I don't know.
Yeah, so like build a for loop. So you know, for item or number in my list. And I can just, you know, write this pseudocode here. I want to check if number is even using modulo. And then what do I do next? So let's, you know, now we have, okay, well, if the number is even, what do we do?
double it, so times it by 2, and then put that value into an empty list, I guess, right? So
Okay.
you have the empty list called at the top, and then so you'd append that number into the list.
Okay, so that's something we need to do before even here. So maybe we like define
Yeah,
a empty list to build answer. Okay. So in the first part now, so we've kind of gone back, we started doing stuff like, oh, we realized, we need to go back and do this. It's exactly what you're supposed to do when you're building this. You won't think of those initial things right away, but you can, when you're talking it out and you're building your pseudocode, you can come up with a way to kind of come up with the answer. So define empty list to build an answer, then build a for loop, maybe list comprehension. I don't know, maybe. So, for number in my list, check numbers even using modulo. If the number is even, okay, so now we know we're going to double it and put it into the empty list. And then, number in list modulo equals, or equals 0 means even. Okay, so otherwise it's odd. So then we do what? We go back in the problem and it says odd numbers are halved. So we need to divide. So divide the number. And then do what?
add that to the list as well.
Okay, so append it. So, or add it to the empty list. Probably not empty anymore, but we'll say empty list anyway. Okay. So there we have these steps now, right? And I think this is pretty good, right? We're defining empty list, building a for loop, okay. And so we kind of think about how we build a for loop again. For number in the list, check if the number is even using modulo, okay. If it's even, double it, put it in empty list. Do I need to I don't think I need to make any new variables at all, do I? I don't think we do. I think we can change things in place or redefine them in place, right? Because we're gonna have, like in the for loop, we're gonna have like our number, and we can take that number and then do things with it and then append it. I don't think we need to make any new variables. But we could build new variables if we want to, just to make sure we're doing things right. They kind of see the process, but we'll just keep it the way it is. Okay, I think we're good. I think we can try and code this out now. And so that's our pseudocode. And so now we can maybe actually code it. And so we're like, okay, so the empty list, what would be a good name? Like when we're thinking about variables, we're going to talk about that here in a bit, but like variable names, what would be a good variable name for this even list? What about the odd numbers? Process list, that's a good one. We can use process list or result or all sorts of stuff, right? But we can do process list. A good thing with IDEs as you use them or integrated development environments, when you have longer variable names, and sometimes you're going to have longer variable names, because you still want them to be descriptive. I talked about that, how variable names, you don't want to be like A, B, C, or X, like in algebra, right? You want to be something that's descriptive, so somebody reading the code knows what it's doing, right? So in this case, we have process list. That's a pretty good result. Like, okay, it's been processed, right? But it's a bit of a longer name. If you're having to reference that list again, what's nice about integrated development environments is that you can kind of start typing it and hit tab, and it will, so it saves it. And so if I were to type it again and do pros like that, PROC, see how I have like all these other things, like, and I can just mouse down or arrow down and hit enter, and it'll fill it the rest of the way. So you don't have to type it. So, sometimes you'll have longer variable names. Little sidebar, but we have our process list, right? And so that we've done that, so that's done. We can go back. I don't know why it keeps messing with that. Sorry, keep scrolling. So next we need to build a for loop. So let's build this for loop. Let's do that, and then we'll take a break and kind of pause on this problem. So build a for loop. So I can say, okay, well, for number, that's a good temporary variable name. So number in, and then of course we know that our parameter in the function is going to be numbers. So for number in numbers, I want to check, right? I want to check if something I want to check the number. So we move on to the next step, and that's if it's even. So so we start an if statement. So if number, and then modulo 2 equals 0. Then I want to double it. So number, I can do this. I can do it that way, or I can just say number equals number times 2. And then I want to move it to how do I do that? How do I move it to process list? Got a question mark.
Process list dot append the parentheses number.
Okay, so process lists, and then just go in here, boom, dot. What if I don't know all these list methods? Well, I can also hit dot and just hit tab, and I can see like some of my methods that I have for lists in IDE. So I want to append it, right? I don't want to insert, I want to append it. And then I want to append number, because I just multiplied by 2, right? Cool. And
Is it
then
all right? The number you're just reassigning the, okay, never mind.
yeah, I'm reassigning here, so it should be. We'll check it. You know, there's other things you can do, and we'll come back to this because there's other things, you know, with problem solving when you do like debugging and coding. Like if you're not getting the right result, like how can you see what your code's doing? Like I've shared some of those tools already. Like remember the Python tutor and the steps and everything else. So let's pause here. Actually, let's pause here and let's take a 10-minute break because we have been going for about an hour and 10 minutes, you know, with the Q&A session. Yeah, you can use print while you're coding. You will definitely want to do that. So yeah, let's take a break for 10 minutes. I will take a short break myself, but I'll be back in like 3-4 minutes. So I'm gonna pause the recording for now. All right, welcome back, everyone. So we left off with a function that we're writing, kind of going over these three items. Developing your algorithm, kind of problem decomposition, and kind of identifying the problems, looking at constraints, and we pseudocoded the answer to this, what we think is going to be the answer to this function, this process numbers, right? And so we left off where we were checking to see if the number, is evenly divisible by 2, or using the modulo to come up with a remainder. And if the remainder is 0, then it's evenly divisible by whatever number you put after the modulo. And we're saying, hey, we want to multiply that number and then add it to the process list. And we went over and we thought about, how we're going to build it. We actually said we were going to have a kind of a container to put our answer in. So this process list, and we thought about the naming of the variable, and we thought about our methods. Now we know process list is a list because we defined it as such. When we hit this, dot and we hit tab, we can see all of our list, our list methods that are included with Python. And we said append is the best because we just want to put the number in there. And as we append things, we're appending to the end, which should maintain the same order from the original list. So with that, we have a number. But now we're like, well, if the number is, modulo 2 is equal to 0, it's even, then we need to have another statement. We have our if here. So what's next? What should we put below that? So the next if statement needs to be for the number being divisible by 1, or we can have just an else statement. So Tim, you gotta be careful with that because, if the number is divisible by 1, that's any number, any whole number anyway. So we actually just need to do an else statement, because if it's not even, it's definitely odd. So like when you're thinking even and odd, that's almost like a Boolean statement, right? So if it's either even or odd, it can't be both, and it's really not in between. So we're going to go ahead and say else at that point. So else, we can say, well, we need to, if it's not even, otherwise it's odd, and we need to divide the number in half. So and finish that. So divide the number or half the number. Yeah, so divide the number by 2. By 2. Okay, so here we can say number equals number divided by 2. Okay, and if from doing these mathematical operations before, when you do a division operation, you are going to end up with a float when you do this, but we actually need float because we realize that if you're going to divide 3 by 2, you're going to get a 1.5, so you need to make sure you have a float. So then we can just kind of do the same thing. Process list.append number. We can do that like that, and then we can run this loop, and then we could return this, or we could just print out process list. Get rid of this pass. We don't need a pass anymore, right? Okay. Do we think this will work? Let's find out. Let's play it and see. Look at that. So 4, and then 1.5, 8, 2.5, 12, 3.5. Looks like it works. Cool. Let's do another one. Let's make another list. Let's do 245, 670 minus 86, 0. I think I have an extra square bracket there. There we go. Run that. Okay. Sweet. Looks like it works. There's still some more. I'm going to go over some more things, but let's just say, for example, we have that. And let me clear these outputs. Let me comment this one out. We can run this, right? So now we have some results that really don't make any sense. So we didn't realize we have that. We can always do some debugging and some ways to debug. And one of those is a print statement. So you can add a print statement anywhere. You don't have to. And what's nice is the print statement will come out while the function's running, and you can see stuff come out. So I saw the question earlier. Should we be using print statements while coding? Yes, you should. If you've already you're starting to write a solution and you're coming up with weird answers, like something that's unexpected, right? So you have some test cases failing. Like I know in Replit they have the test cases, and if they're not passing, you want to figure out why, so you can fix your code. You could always just do a quick print statement here. You want to print your number there. and see what's going on with it. Especially if your list is like hundreds of items long, right? You just want to kind of see what's going on, or you can go ahead and feed it some test values to kind of to see what your number is going to come. So if I go ahead and run this, it's going to print out some of these, some of these results before it gets to the answer. So I know when I print, like I know that I'm in this logic block. So I can then kind of fine tune what's going on. Like that's not the result I want. Let's take a look at this new number. Oh, I have an extra. I'm doing the floor division instead of doing that. If I run it, now I'm getting the right result when I run this. And you can use that print statement. In this example, that's not the best example, but if you're, we'll definitely use some print statements in the lottery simulator that we built. So print statements are pretty strong for debugging. Of course, you have the Python tutor. That's another one. You have your IDE debuggers where you can stop logic at a point using a breakpoint, where when you run that, the code will stop and allow you to step through it. In this case, I would have to see. I don't know how to use this actually for a Jupyter Notebook. I've never used debugging. I think there's ways to do it. Run line by line, so I can run line by line if I want to, and kind of see the whole process. That's kind of cool. So that's another debugging tool. You can kind of see what's going on for each. So continue execution. Oh, looks like I was up here. I meant to run this one. Okay. Yeah, I'll have to play that. I've never used it for Jupyter Notebook, but that's a way you can use that tool as well, a debugger. And so you want to fix, so when you're doing that, you want to be very systematic when you're fixing your issues. So if you have an error that pops up, you can use that stack trace, the error message that pops up, and it'll tell you what lines you have issues. And typically it will start with like a function call, and then you'll find an earlier one that actually goes into that function and tells you what line you have an issue. So that's a way you can debug as well. Another when you're translating your algorithm to Python code, you want to make sure you write clean code. I think here we wrote really clean code. It's pretty easy we thought about our variable names, and we thought about, how we're going to structure this with a for loop and then putting our if statements in there. But we also have the PEP8, which is like coding. It's kind of like the, I have it over here on my bookshelf. It's when you're writing papers, the guidance for writing college papers, and PEP8 is kind of the same thing for Python. So you take a look at it. Let me go ahead and pull it up. Move this over here. We have Python PEP8. It's a style guide. So here, this will kind of tell you. It'll give you a kind of a layout. It's pretty good read here. It tells you about how Python should be. And it talks about I think there are some things about like Python and being readable, and how if you use like methods from PEP8, in the styling, that if it makes it less readable, then you can violate that. Or if your team uses two tabs or tabs versus spaces, you want to make sure everyone's on the same page so everyone can read your code. So yeah, APA, that was it. Yeah, like APA format or the other ones, that's what I was talking about. PEP8's kind of that for Python. And there's a whole bunch of stuff on this. Now you give your contents here, and it talks about, everything, commenting your, how do you put comments in here? Is this the right way to put comments in? Probably not, but I'm just pseudocoding. I'm not going to keep this in the code. I'm going to take it out. Do you keep comments in your code? Sometimes you do, sometimes you don't, depending on, how it's being used. I got flagged on code comments just today on some of my code on one of my contracts, because I had left comments when I was submitting it to be put in, and I had to go in there and take it out before it got approved. So there's a bunch of stuff in here. I know you probably can't read it. I don't have it zoomed in, but it's just it's a pretty good read, and will help give you some like framework on how to style your Python. You know, when we think about like with code, you know, you don't typically want to repeat yourself in code. And so in this function here, there's actually a place where I repeat myself. And that is right here. So in this case, I'm saying process list dot append number, but also here I'm saying process list dot append number. Now I'm only going to hit one or the other, but I'm still repeating myself. Do I have to put this code here? Or can I put it somewhere else? And only put it in one time? Well, I don't want to return. So when you return from a function, the return stops the function completely. So I won't finish any more iterations. But I could actually do this. So because I'm still under my for loop, I'm under a single iteration, I'm going to hit one of these blocks and adjust the number. But until I leave the loop, number is going to stay. So because number is a temporary variable, it's going to change every time it iterates. So I should be able to just type that once, and this code will always be hit, regardless if it hits this one or this one. So let's see what happens if I do run that. There we go. So now I repeat, I got rid of one of the parts where I repeated code, because all I need to do is change number. I didn't actually have to append it there. I could have waited till after the if or else, the if else statements to append. So not something you need to worry about now. Again, we're looking for the basic qualifications, right? You know, manipulating data. You'll learn if you get into Platoon, you're actually going through, you'll learn about all these steps, but this is something to think about. You know, this is just more of like an introduction. So, you know, if you have exceptions, you can handle those gracefully. There's blocks called try and except, where you can have Python try code, and then if it gives you an error, you can give it a graceful error instead of just a simple like exception that's usually easy to read, but it still can be confusing. You can add your own custom error statements in there to come back to the console or to a logger, so you can see like where an error is. Again, nothing you need to worry about now, because right now you're worrying about passing test cases and failing test cases and dealing with those. So moving into testing and validation. This again is also more just conceptual for you. You're not going to have to worry about writing test cases, but you've seen test cases in your CoderByte challenges or in Replit. They have some test cases in the bottom. There's a whole testing module in Python where you actually run tests on your code. And I have it illustrated here, and I just wanted to kind of show what it is. There's actually a concept with coding, and it's called test-driven development, where you write your tests before you actually write your code. And what it does is it kind of forces you to think about, the potential edge cases that you have. Because when you're conceptually thinking about a function to write on, like, in this case, it's a very simple addition function, right? When you're thinking about like what's going into your function, what's coming out, like in this one, it's easy. Like, well, I want two numbers to go in, I want one number to come out, and I want those numbers to be added together. And so you could write like tests based on that without actually having any logic in there yet. And then what you can do is then write your code as you're testing it to see if that you're meeting each one of those test cases. In this case, like, let's say, we just don't know how to add it all. And I'll have to move to a test module, but let's say, for example, we're like, well, I know I want to keep like A is going to be equal to absolute value of A, and then return, this is a silly thing to do, but return A plus B. Okay, We could write that like that's our, we pseudocoded and we thought this is the best approach. Obviously you don't want to return the absolute value if you have negative numbers and you're trying to get the actual value of those two added together. But in this case, I moved over to a actual file so we can see this run. Let me go ahead and put that in there real quick. So A equals absolute value of A. And so at the absolute value, what it's going to do is just give me always positive version of whatever A is. So if A is negative, it will not give me the right one. Or it won't stay negative, it'll stay it'll go to the positive. But let me go back to terminal here. Let me clear and make this a little bigger so you can see. Make it one more bigger. It may take a minute. My computer's struggling today. There it goes. Okay. And so this is here it has like, here's how you run tests, right? This is the unit test module. And this is my method. Normally your method will be actually in your code base, and then this test will be a separate file that will then take a function and kind of isolate it and then run it with certain conditions. And so in this case, what it's doing is it has a result right here, and it's asserting that when it runs the add function with these two items, that it's going to come out and equal this. So it's asserting that's going to happen, right? And it's using positive numbers here, and then it's using negative numbers here. And you can already tell, like, if I use absolute number, like, this is going to be a 1, and then I'm not going to get a -2, right? We can see that. But you could run tests and just build this stuff without actually having any functionality in your function, whatsoever. In this case, I can actually comment this out and just put in, return, or I can just return none, right? So I can just return none for now. And then I can run this, and it's going to say, like, kind of how many tests I ran, and then give me some errors here. And it says assertion error, none does not equal -2. So I'm like, okay, well, I don't have anything in my function right now. So of course, but at least I have my tests. And now I can go ahead and put some code in here. And so this is my first result that I come up with there. And I have that. So I run this again. And it looks like I have now only one failure. So I failed the entire suite. That's what this means here, but I only have one failure now. But it looks like the other ones passed. And so then I need to take a look at, okay, well, oh yeah, silly me. I don't need absolute value. I can just run that. I need to keep my number the same. And if I run that, ran 3 tests in that amount of time, and I've passed all my tests. So this is just a quick view of how test cases work in Python. In Code Platoon, you will write tests. You will do this stuff. So when you're writing code, test-driven development is a good way to kind of write code that is less error-prone. So, any questions on that? Again, this is just a good view of it. You won't need to actually use this in any of your coding for now. As far as optimization, I've never done any big code profiling. I have done some timing of my code. They kind of, I'm using the time module to kind of see how long things run. But you can, there are packages, and I have some illustrated here. And here, I believe it's right here. It's called C profile. And what this is doing is this will like give me results on how something has run, and give me like how much cumulative time we've had, or like how many calls to a function has been run. And it'll help you find like where in your code, like you have things that are happening way too much. In this case, like I'm doing this weird, like, I'm doing this weird thing where I'm summing like values in the range of 100. And if I do that, I'm going to get the same result. So why would I use that? Maybe I can use a constant instead of recalculating sum. So in this case, I can go ahead and, take a look at what it is. So if I run a print statement right here, like print a sum, and I run this again, now I see, well, it's always 4950. So I don't need to worry about like doing this and running another for loop in here. I can just put a constant in here. So in this case, it's 4950. I'll go ahead and get rid of this print statement so you can see the results again and run that. And now I've dropped my function calls to 10,000 versus 30,000. And so that's a way you can kind of, use this library to kind of see where you have bottlenecks or things that are iterating unnecessarily. Again, probably not going to use it in your development with these exercises, but it's just something you can do as you get into Python development. Any questions on that? These last two sections here really talk about not just, solving problems on your own, but like solving problems with your team. So in a coding team, you're going to be constantly talking to each other. You're doing code reviews, and when you have your new code, you want to merge into the main development branch. You have to do what's called a pull request, which is like a request to merge your code in. And so like you would have already checked it for like any kind of like code smell issues, making sure your code is efficient. There's other like linters that will automatically check your code for weird variable names or unused code, and you'll run all those tests. But then someone's still going to review your code, and then as a senior developer will look at this like, hey, why'd you take this approach here? Do you think maybe using list comprehension could be easier, or do you think you need to have so many variables? Is there something more efficient? And you'll communicate those things. I had one person ask me on my machine learning model about the memory. I was talking about the memory issues earlier. Like she was like, why are you saving them already then? And then on the next call, like the user just moves them. Why are you doing that? Why don't you let that end and then have the user specify where you're going to save them? And I was like, well, I can't, because if I run all 7 loops, I run out of memory. So I have to like run them and then allow it to finish. And then I save like a checkpoint file. So they are being saved, but I also need to use this call to move the files where the user wants, but I can't use that until it's done training. And so I was kind of in this situation where I had to kind of pre-save something somewhere, and then the function of them actually saving their model was just moving a model. It was already saved, but they need to move it to where they wanted. And so, that I got questions on that and I answered it, and like, oh, okay. And so the communication in your team, when you're talking about when you're seeking feedback from peers and mentors, that's it's communication is a big part of being on an agile team, on development team. And so documentation is big. So a README, you've been looking at READMEs, these markdown files in these lessons. You will use this markdown language to kind of document your code. So, part of it is building a README file that will explain what your code does. And then that becomes part of your code base. If you've already gotten into GitHub and started looking at like public repos of things, I mean, people have public repos over all sorts of stuff they've written that, for academic challenges or some they're just kind of interested in coding. If they're, following good coding practices, they'll have a README that will explain what their code does, how to set up your environment to run it, so on and so forth. So that's kind of like the documentation piece, and then updating your documentation as you make changes to your code. Writing those clear code comments. And so in this one here, like this inefficient function, there's 2 places you can put comments, or you can have a doc string. So typically with a function, you're going to want to write like what the function does. Right. So again, we have clear function names, clear variable names, but sometimes that's not enough. Sometimes your function is still very complicated, and it needs something a little more. So with that, you may need like a doc string. So find max product in a list numbers. This right here is documentation that tells other developers what your function is doing. So it finds the maximum product, 2 integers in a list. Arguments or parameters are numbers, and they're in the list format. So, and they're a list of integers, and then it returns an integer, the maximum product, 2 numbers in the list. That's what my function does. That's what the documentation piece is. So, so that's important to, writing code that's readable by other developers, because it's not just going to be you writing code. You're gonna be writing on team and adding code to a collective code base. And then you can have line comments if explaining things sometimes. So you can have a comment here and just say nested loop to find the other number. You can have something like that. This is a quick inline comment, or just a quick line comment to show what's going to be happening here in this next line. So all those comments, they want to be clear, concise. You don't want it to be all weird. Just a quick statement on something. Actually, today I cleaned up. So again, I grabbed code from academia. It's these folks are very smart when it comes to machine learning, but they don't write very clear code at all. And I can actually, let me see if I can copy the example I had. Let me see. Go back. I think I have it on here. Recents. Oh, I don't think I have it on my iPad. I think it's on my other app. Anyway, the comment was a square bracket with C, comma, I, comma, H, comma, W. And then it had an arrow, and then it had, I think, I, comma, H, comma, W. And that was the comment. It was like, what does this mean? What is this? Like, I had context. It was something with machine learning, but I used ChatGPT. I was like, hey, take this code and tell me, like, give me context to these comments, because I don't understand them. And then it actually broke it down and said, oh, looks like these comments are relating to, it looks like the 4 characteristics of a tensor, and it gave me each one. It was like, you're looking at height, width, and you're looking at channels, and I can't remember the other one. It was like, I was like, oh, cool. And I was able to write my comments a little clearer, so next person who uses this code can actually read it. And so that was a good example of that. And I can share that example later if we're when we're going over some of this stuff. So I'm on Microsoft Teams at work. With Code Platoon, we use Slack. So Slack is big, and I've been encouraging everybody to use Slack. Not only to do like a DM with me on a problem. You can totally DM me, and I can go over a problem with you. But it really would help the entire team, the entire class, if you have a problem, just put it in the main chat. I mean, and someone can help, chime in. Usually you get help faster that way too, especially if, it's in the middle of the day and I'm working, I don't actually see a Slack communication come through. You can get help a little quicker. So using, communicate your changes, communication is only as good as, the people using it. So if you're using it more, better communication typically yields better results. Version control systems, Git and GitHub. GitHub is a version control system. It's a online for big teams to use Git, which is more of a computer installed system to do version control. You'll learn all about that in Code Platoon as well. And then, of course, fostering a collaborative development environment. So being nice to each other, like if you'll run into some developers who are can be jerks sometimes, and they can really make you feel bad if you're new at it. So it's dealing with that as well. You always want to be positive and constructive with people, and that's why I encourage any question, no matter if it's over strings that we talked about in day one, right? I don't care. Ask a question. You're in a learning environment, and that's the we're going to give you an answer and you're not going to be ridiculed for that or belittled because you don't know this by now. That doesn't matter. You're trying to get into a coding boot camp. Of course, you're not going to know much. So that's where you're gonna. That's the best thing to do is ask it in the public room. And so that's really it. Like this one here, we're going to talk about. I think we're going to talk about our lottery problem here over the rest of the class for the most part. And we talked about one of these problems together. I hope this lesson kind of illustrated the problem solving techniques that we have as developers, gave it a little more formal definition. Hopefully some of the stuff was new and will allow you to maybe solve your problems with these coding challenges a little easier, because that's the goal. And so that's really the end of the lesson. Does anybody have any questions on the content, what we went over, or the challenges? Again, we're gonna kind of step back and go into the lottery challenge, kind of start building that. But any questions on any problems you've done before or any data types? We can answer those now.
I'm having problems and trying to compare stuff from one part of my list to the next part of the list, and a lot of the coding challenges are sort of like you need to compare this value to the value next to it down the line, and I'm getting really stuck on that, and I don't want like you to solve the problem for me. I just want to know like the sort of like, I don't know if I'm supposed to be using a nested function, or I mean not a nested function, a nested for loop, or like I'm just having like, if I want to know like if my number at index 1 is greater than the number at index 2 is greater than the, or like add these two numbers, like from just getting from the next index to the next index to the next index and doing something with it. Does that question make sense?
Yeah, it makes sense. And there's ways where maybe you can, if you're going to be comparing like neighbors to each other, for example, like let's say you're always going to compare 1 and 2, then 3 and 4, then 5 and 6. Maybe you can try and split those two into 2 separate lists, and then run a loop over both of those separate lists together. So then you only have to run one iteration. You could do that. So if you have like, a big list, so my big list equals, let's say this is a giant list, right? And it goes to 900 versus just 9. If you're always like going to be comparing like this one to the one next to it, and then maybe this one to this one, you could try splitting it. So you can take, you can iterate over my big list and use the step. So when you're iterating or using a for loop, you use a step method to just hit every other one and then pull that value out and put it into another list. You could try that. Yeah, I just think really a lot of like, just trying different methods. Again, you can always make new variables and new constructs of what you've had initially on your input data to do some comparisons. Again, if you're trying to compare neighbors to each other, like down the line, typically a nested for loop is going to be your go-to. And I think this is actually one of them. This is one of them where you're doing like a range and then another one, but you're grabbing the next one up. So you're starting your inner loop with the next item, and then you're going to start multiplying them together to find the maximum product. And then you need to save whenever your max product's the highest, you want to save it, you want to reassign this as the next higher values. And when the next comparison goes on, if it's not higher, it'll just keep going. If it is, then it'll reassign it again. That's exactly what this one thing is doing, this one problem. Does that answer your question? I guess, I don't know. I mean, there's,
I'm not sure. Maybe I'll like think of a problem and re-ask on Wednesday.
okay. Yeah. Yeah, I mean, this one here is doing a comparison and multiplying them together. That's exactly what this one function is doing. Find the max product of of two lists, or two of one list, and it's just, and it's comparing all of them together to find which two are going to give the maximum product. And so if I were to run this, I get back 161. So if you take a look, 23 times 7. There we go. So 23 times 7 is 161. So it went through, iterated this list, and it found the 23, and it found the 7. And what it did was it started with the 2, and then looked at 2 times 3, then 2 times 23, then 2 times 4, all the way down, and then checked the 3, then checked the 23, and then it found, okay, this is going to be max product. And then once it defined max product, the rest of the time it ran, product was always less than max product, so it never changed. It stayed 23 times 7. That's how it came back with the max result. So, I mean, that's how you compare neighbors to, like, in a list.
Okay, thank you.
Yep.
And then could you go over enumeration again after, if you have time at the end of class? Because
Yeah, we can go over
Okay.
enumeration right now. So if I have a list, so my list equals all right, so A, B, C, D, F, and then so it's 4 index value and enumerate my list. And what does enumerate do again? Well, it returns an enumerate object, which gives you an iterable. So it gives pairs containing the count or the index of the item, and then the actual value. So I can say print here, actually I do an F string. Here is my index. And here is my value. So here's my index 0, and here's my value A. Here is my index 1, and here is my value B. And so now if I kind of know everything about my list now by using enumerate. And you can use that to reference, you know, if I need to change something at index 4, I know it's going to change the E.
and does this create sort of like a tuple, or I know here it's creating a string, but if you were just to like enumerate, it would throw you out a tuple and be like A at index 0, B at index 1.
So you're saying what to print what, like
Just the index and the value. Like if you just were like if you're going through and you're like, I just need to find the index of every single thing so I can look at and compare for an unknown amount of like information that's coming in. You know what I mean?
I guess I'm trying to understand what you're asking.
I I just want, like, what type of stuff is it printing out at you? Like what is getting regurgitated to you? Is it a string? Like what is that data type?
I mean, I can also print the type right here. So
All right. I only ask because I try and get and do these challenges, and sometimes I get these errors and I'm going through and I'm just trying to figure out like what I can and can't do with certain like data types. And I
Mm.
tried to use enumerate and I like got myself all back into a corner.
yeah, I just with Numerate, what's nice is it gives you indexes and values, so you can kind of then use all of your list methods on anything, right? Because some list methods require the index, some list methods require the value, right? So if you use enumerate, then you can kind of get both. You kind of get what index is for what value, and you can use that to your advantage because you can then say, well, if you know value is, let's say you want to move the D to the end of the list, right? Well, one, you can then pop that D out using either the index or I think it's pop or remove. I have to always look. I have to look at the mess. I don't have them memorized, but you can look them up, and then you can use your index or your value because you have both in the loop, and you can use if statements to kind of catch whatever one you need based on that. So there's more than just printing. I can do all sorts of stuff, right? So if value is less than 6, or no, let's if value is less than 3, I want to remove that. I want to remove those values. I can do that, based on that. Or if or not value, if index is less than 3. So if index is less than 3, then I know I'm going to remove the first 3 values because I'm going to get 0, 1, and 2. And I can use that to manipulate data and change things in my list, depending on whatever my requirement is. And
Say
again,
you had like,
oh, go ahead.
no, I'm sorry.
No, go ahead, please.
So say you had like E in there several times, rather than saying for index in value, could you do like for index for E, or do you have to somehow go in there and be like if E in my, and then go back through, like say you only wanted the indexes of where E shows up. Would you have to enumerate the whole thing and then from that go through that list or whatever data type that you created, and then pull out that value? Or is there an easier way to do that?
So if I did this way, right? So if I wanted the index of all the E's in there, and let me just throw a couple more E's in here. There's one more E, right? Run that. Hold on.
Would it be not in a string? Like value, just be value?
Yep, that's what I did. Here we go. There's my indexes where all my E's are.
Okay, thank you.
Is that's kind of what you're looking for? Some way to find something? That's a perfectly valid question to ask here because you're not really asking a specific question. You're just kind of asking for a tool for like a small portion. That's completely fine.
Okay.
So cool. Let me go ahead and stop the share because we're going to go over this lottery thing. Unless y'all want this recorded so we can kind of go over this lottery thing.
I personally like the test cases getting recorded because then I can go back through and actually look at like what like the examples are, and that actually helps me a lot.
Okay. I mean, yeah, we're going to be kind of just going over this lottery, kind of breaking down the problem a little more using some of these problem solving techniques we had. So not necessarily putting much code. We need to put some code in here. We'll see. Let me make a new file, actually. I think I'm going to do that instead. Let's do lottery simulator. Let me grab this. Okay. And so, we talked about the lottery simulator and kind of like some of the sub problems we had, right? With like, okay, we need to code a ticket, right? We need to get a ticket. And we need to have a drawing, and we need to be able to run that drawing multiple times. So there's a lot of stuff in here that we can break down into smaller problems. But we already talked about the ticket. So let's start with just the ticket. Let's go ahead and code a way to like get a lottery ticket, right? So what does a Powerball ticket consist of? Consists of numbers, right? Are they floats?
Whole numbers.
Whole numbers, right? So integers. So we just need a list of integers. So let's go ahead and define let's do a ticket. So we're gonna make a function called ticket, and let's spell ticket correctly. And right now we don't want to take any parameters in. We're just going to define a ticket. And we're going to pass. So we're making a function called ticket. We may change this later on, but let's just right now stick with this ticket function. And let's do some pseudocoding. So I want to have a ticket. I want to have numbers, right? So what do you think the best type of data we best to hold a ticket, to represent a ticket?
Can you I don't play the lottery. Can you have repeat numbers in the lottery ticket? So there would be
No.
a set, right?
So it's a collection of balls in a bin, and once one ball is removed, it can't be called again. Now it can with a Powerball, so that like the Powerball is a separate bank of numbers. I think it's 26. I can't remember exactly how many numbers it is. But so you have like 1 through 75 in one bin, and 5 of those numbers come out, and then you have another bin, a separate bin of 26 numbers. So you could have like a 2 in your main drawing, a 5, and then another 2 in your Powerball. That's the only time you can have repeat. So
So at that point, would it be sort of like, I would say a set, and then you could do 1 and then every single variation, and then 2 every single variation. That would be a lot.
right, we're not worried about like any kind of variation right now. We just want to make a list, right? We want a function to create a list for us, right? It won't matter about numbers. I'll explain how we can get the random numbers here in a bit. But right now we just want to build a ticket, and what data type, lists, sets, dictionaries, tuples, which one would be best to make a ticket? Does a ticket change? Do make sure it's not changeable? So, okay, so we can make it a tuple, maybe like a tuple ticket. And it's going to have how many values in it? So it's going to have 5 numbers and then a Powerball. So 6 items long. A tuple ticket, 6 items long. And so the attributes are first 5 numbers are unique. Numbers from 1 through 75, right? I'll have to look at the Powerball exactly, but I think that's what it is. So 1 through 75. And then Powerball is a number 1 through 26. And I want to add these to the ticket tuple. Okay. So I want to make a tuple ticket that's 6 items long. The first 5 numbers are unique numbers 175. The Powerball is number 1 through 26. I want to add these to the ticket tuple, like together. Can I append to a tuple? No, they're immutable, right? Doesn't mean it can't be a tuple for now, but you know, we may have to think about that if we're gonna like do some sort of iterating. Like, how am I gonna conjure up numbers out of thin air when making a ticket? We can do a random quick pick, something like that, right? I think the MVP is generate a static user ticket based on a pseudo random number generator. Yep. So I want to do a random generation. Right now, I don't want the user to be able to select the numbers. We can do that later. We can have a stretch goal where, you know, we can have our program say, hey, pick your numbers, and they can pick their numbers and then pick their Powerball and they get a ticket. And then they can, that way they have some ownership of what numbers they chose, right? Right now, we just want to assign numbers to it. So we can't append here to a tuple. So we got to do something else. Maybe we can have like a list initially and then turn it into a tuple. We can like cast it to a tuple. We can change data types. So we could do that maybe. Because you can totally do that. Can you cast a list into a tuple? So yes, to conjure random numbers, yeah, we can do that, right? We can do the casting. So we have a list name, we just use the tuple method to cast to a tuple. Yeah, we can do that. So with Python, there's a module called random, which will allow you to generate random numbers and do all sorts of cool things with pseudo random number generation. We need to import it because that's a module. So import random. And when I do that, you see how it turns like green underlined? That tells me it's a module, and then it can give me like variable generators and stuff. So that's important to have. And so now let's go ahead and, you know, if y'all want to look up random on your own, you know, you can do Python random and then get the documentation for it. But the one I always tend to use is like random.randint, which gives me a random integer from like from guidelines I specify. And so so let's see, I want to return a tuple, but I need to add items to a list first. So maybe I can make like, do you think I should make like an empty list first to start my my code? A random list? We can call it random list, sure. So so random, maybe do random number list, right? So random number list equals just an empty list right now. I just want to have a container to start throwing stuff in. And then how am I going to randomly just get 5 numbers from 1 to 75 into this list? Is there any kind of loop I can do or put in here to add? Nika says range. So I can say for num in, I think it's range. And then I want to do 5 numbers. So I can just do range 5. Let's just see what happens with this first. So let's test this loop to see if it works. So right now we'll just say random num list dot append 1. So I just want to append the number 1 to it and see if it works. So now I can print random num list. I can try that first to kind of see what I get. If I run that, I need to go ahead and specify that I'm using Python. Um, did it work? Oh, I can't see if it works. I have to call the function first, right? I have to call the function. So ticket, just do that. I should be able to just run because I'm calling the function when I do that. So if I run that, okay, cool. Looks like I did 1 1 1 1 1. I have 5. Now random number list, every time I run this will instantiate as a empty list and then run this and I get append. But I don't want to append to 1. So I want to append the random number. So I can do, if you look at the module, you can kind of get some, constraints or some guidelines for this module and kind of the different functions it has. But one of them is called random.randint. So this actually tells you what you can do. But I want randint. And then I want to return a random integer in a range, including both endpoints. So basically I have A and B, and it's going to include both. So I want 1 through 75. I want to include 75. So I'm just going to do 1, 75, like that. Okay, so I put that in there. If I run that, looks good. I'm running it over and over again. I'm calling it, just running the cell over and over again. We get a different result here. And so I've now written just looks like really it's 3 lines. This print really doesn't count. Like 3 lines to create a ticket with the 5 numbers. But I'm not done because I have to add the Powerball to this as well. What could I do to add the Powerball? Another for loop? I don't know if I need to do a loop? What do I need to do now? Because I have my 5 numbers, right? From 1 to 75. But remember, the Powerball also has a Powerball number that's 1 through 26. And so I need to add that number in there as well. So I did the for loop to get the 5 numbers. Do I need to do another loop to get the Powerball number? Yep, I can use random again. But there's only 1 Powerball per ticket, right? There's not 2 or 3. So I don't think I need to use a loop. I just need to get a number between 1 and 26. So I think, yeah, you can just write the line below outside. So you let your loop run and then just append another number at the end for your Powerball. So I can just say random num list dot append random dot randint 126. I should be able to do that, and now I should get 6 numbers. And this last one is a special one that only goes up to 26. If you look, every time I run it, I'm not getting higher numbers there because it's only going 1 to 26. So there's my ticket. I have a ticket as a list, Then I can go ahead and cast that to a tuple if I want to, right here to make sure it stays permanent and it can't be changed by I could then just cast it. So tuple random list. And I can run that. Can print that. There we go. There we go. This is a tuple because it has the parentheses now on either side. So, of course, with a function, there's what are the components of a function again? We have our definition of the function, so our name of the function, right? And then we have our parameters. The parameters are, whatever's coming into the function, and then at the end, typically I want to return something. You don't have to return something with a function. In this case, I probably do want to return my whatever I'm doing. So in this case, I would either just do a return statement here. So return tuple random num list. That should work. And I can define my function call as like my ticket equals ticket. And then if I print my ticket here, I should get back my ticket. Oh, very good. So Athena just asked a question. Does the random module itself know not to print out a repeated number? It does not. So that's the first now constraint that we didn't identify when writing our code. And so now we have to think, okay, well, now if I'm running this, I need to make sure I'm not getting a repeated number. So that adds a bit of complexity now to this problem. We thought we were like cruising right along, like, oh yeah, boom, got my list done, right? But if I run this enough, it's going to take some time, but we haven't gotten a repeated number when we looked at this, right? But then we've just been running on our own. Eventually we're going to run into a situation where we get a repeated number. Let me just do this. Or 10. Try that. No repeated numbers there. Anyway, we will get a repeated number. So, so we need to do something in our loop, like with our whole construction of how we do this, right?
Aaron, you can have one repeated number, just not the whole line of repeated numbers though, right?
Correct. So I don't think we have to worry about checking the Powerball since we're calling that separately. So we can leave that part alone. We don't need to worry about the Powerball portion, but we need to worry about these first 5 numbers, make sure they don't repeat, because then you don't have a valid ticket. Ah, Wes says if statement to check if it's in the random num list first. Okay. Now, if we do that though, like, I mean, we can put an if statement in here and be like, okay, if number is already in there, if number in random num list, then do it again. Or like, how would I, like, what if my loop just does a bunch of repeating numbers? Like, how do I solve that? I'm using this for loop and I'm iterating a certain number of times, right? So in this case, I want to do it 5 times, but I may have to do these checks 20 times. If I'm unlucky enough to keep getting a repeating number, how can I deal with that with a loop? Okay, let's explore using if statement, right? So, well, I mean, we know like the first time we put a number in, it's not going to be repeating because it's the first number. So we can say if len random num list is equal to 0, then I know I can do it first time. Like it doesn't matter. Or cast it to a set, then check to make sure the length is 5. Or maybe, yeah, or maybe use a loop to add things to a set and then but see that doesn't change. Like I'm using a for loop with a finite number of iterations. Like I almost need to have a flexible number of iterations. I think this is a while loop, maybe. So instead of for num in range 5, maybe I can do a while loop. But what would my compare? So a while loop runs based on a comparison statement that's true. So I want to run until that a statement evaluates to false. So I have a while loop. So while, like, what I want this loop to run until something gets done. What do I need to get done? Len less than 6. Oh, still have it go until 5, I would think. So while len is probably less than 5, because the last one's going to give me the Powerball, which is not part of my loop. So while len random num list less than 5. So that's going, so when it's not filled up, it's going to evaluate to true. So while the length is less than 5, I want to do my thing. I want to add numbers to this list, right? Okay. Dustin, I'm not forgetting you here. So could you make into a dictionary and have the key be each try and numbers be the value? We could, and we can come up with a solution there too. Let's go forth with this idea of a while loop right now, and maybe we can circle back if it doesn't work. So while it's less than 5, if the length of the random number list is 0, so I could probably get rid of this because I was writing that in the other one. So let's try this. So actually, you know what? Let's keep that for now. Let's just go ahead and keep that logic. So if the length is, I want to go ahead and run it and get one number in there, right? So I guess now I have one number. So now if else I want to I don't want to just do a straight up append. Maybe I should make a variable like here and then check to see if it's in the list already. Now that it's run once in this first if, right? The first time it runs, it's going to hit this logic because it's going to, when it first starts, the random num list length is going to be 0. So it's going to add a number in there. So yeah, maybe I should say, well, else number, let me see, number to add equals random dot rand int 175. I moved extra D in here. And then I can do an if statement here if number to add and check for membership in the random number list. So if number to add is not in there, I can then add it, and then otherwise just don't do anything. So iterate. So I can say if number to add not in random num list, I'm going to move this over a little bit so we have more space. There we go. If number to add not in random num list, then I can append it. Do you think this will work? So we have while length is less than 5. Okay, then it goes into the first if statement. If the length of random, so I know this is right here saying, hey, if you're at your first iteration, just go ahead and throw that sucker in there because it's going to be a unique number. And then otherwise, I'm gonna define a variable called number to add. So each time this loop iterates, it's gonna kind of remake this number, right? And it's gonna give me a random integer. And then if that number is not in my random number list, then I can add it. And then this will run until it checks to see that it's 5. So I run this. Okay, looks like it works. And I think this way I'm guaranteed to not this way I'm guaranteed to not get a repeated number in these first 5 numbers. And then it can repeat here because that one's a separate entry. And then we get our final result and we want to return the tuple of random num list, and that's what I'm doing. So I'm defining my ticket as the return of this function call. So I'm calling ticket as my and let's rename this to ticket generator. And then that's a clearer name, right? So ticket gen. So ticket gen is running that, and then I'm getting back my ticket. It's a tuple ticket 6 items long. First 5 numbers are unique numbers from 1 to 75. Okay. I think I have that. I can always write unit tests too, to check that. But you know, again, this is just an intro into unit testing. We're not going to worry about unit testing right now. But it would be a good idea in a situation like this. And then we're gonna say, well, so I'm gonna start iterating through this loop. And the first time I run through it, because there's nothing in it, I want to add my first number. And then otherwise, I want to check. So I want to check number to add, make sure it's not in there. And if it's not in there, add it in there. So that's going to add unique numbers 1 to 75. So if this loop may run, more than 5 times. In fact, I can do that. So loop count. I can track that. So loop count equals 0. Here, I can just say loop count plus equals 1. And then here, I can run at the end of this loop count plus equals 1. And then I can print at the end of everything, print five, 6, 5. So one time I hit a repeat and had to loop again. There's a 6. I'll try and stop it on a 6. Could do 7. There's 6 right there. So this time, the random number generator hit one of them, and it had to do an extra iteration to make sure it wasn't added. And so you can kind of throw like a counter in there. That's a common tool for like counting things, like counting loops and other things. You know, if you only want to run a loop 3 times, but you're dependent on another situation, you can throw a counter in there, and then in your if else statements, you can just iterate or increment that loop count. Just make sure you assign it outside of the loop. That way it's not affected by the loop. So in this case, I just made a quick loop counter to see if, to test, like a quick little function test, and make sure I'm actually seeing multiple, like, or number being hit at the same time, and then it rejecting it, which it did, because I do not have a repeating number here in these first 5. So I think that satisfies our results with making a ticket in our lottery generator. And we have one function that can do that. Right now, we can just make a ticket, and it's a valid ticket that is, it's a perfect Powerball ticket. And so our next step, so we have a ticket now. Now we need to generate a drawing.
Hey, Aaron, real quick.
Yeah.
Is it, I'm a little confused to where what you're trying not to make the same, because I would guess that I thought we're trying to make the whole set or the whole list not repeated, not just, but like you can have all 75s, but nobody else can have all 75s. It only prints out one of this particular set or list of numbers.
Right, this does. So, well, the constraint was these first 5 numbers can't be repeated. So they have to be unique numbers, because in the lottery, there's a big hopper of balls, and one gets pulled out. There's 75 balls in there. And when one gets pulled out, once it's pulled out, it can't be pulled out again because it's gone. So I need to have a way. So in Python, I need to have a way to kind of simulate that with random numbers. But I wanted to make sure each number had an even chance of being pulled out. So I had to pull each number individually with this random module. And that's what I was doing.
Oh, okay, I got you. I see where I was misthinking
And
that.
you know,
All right,
it's,
thank you.
yeah, and this is not entirely accurate either, because, you know, I need to actually do a random, like, integer. Once one gets pulled, I need to do 1 to 74, because, you know, but I need to make sure I'm not going to, you know, I need to almost have like a whole bank of numbers, and I need to remove a number from a list and then randomly pick another index. So to be true to how the lottery works, I would need to do, like, I need to have like a set, like a full list of numbers. And then when I get an index from a 1 to 75, I need to pull that number at the index, then actually pull it from the list, and then do another random pull. I'm going to approximate it this way for now, because, you know, I'm getting into a bit of the fine details. You know, I just want to make a lottery simulator, but it's not entirely perfect. This is not entirely perfect because I'm doing 1 through 75 over and over again, then pulling a different number from a bank of 75, when in fact it'd be 75, then 74, then 73, then 72, then 71. That's actually how it'd be pulled. And so it works out a bit differently mathematically, but it's really not that important for the sake of this lesson, because I'm just trying to show how, I mean, look how many things we've talked about in just making this function. We talked about functions, we talked about the parameters, we talked about the return values, we talked about loops. We initially started with a for loop, and then we realized, oh wait, we can't have repeats, we need to change that to a while loop. And then we talked about using the length of a variable or of a list. We talked about lists, we talked about tuples. We've gone over casting data types from a list to a tuple. We've done a lot in this short hour of, you know, going over just making this ticket generator, but it's important because each one of these separate things I'm doing is a tool it's a tool in your toolkit to make something, create something, and that's what we're doing here. We're creating a solution to a problem. The problem being, we want to build a lottery simulator. How can we use our tools that we have to do it with this programming language? Yeah, Melanie. Randint, again, this is just the random module. It's a library or a module in Python. So you can see here it says module random. It has its own set of functions, and randint is one of them. And what the randint does, whenever you call this method, you need to give it two parameters, and that's the low number and the high number in that set of numbers. Then it'll grab a pseudo random integer from the range you select. So this can be anything from 1 to 1,000,000 if you want. So that's really what it is. Just random is a method in the random module to give me a pseudo random code or pseudo random number instead of having to write that code myself. So it's just it's a module to make things fast and easy. And it's included with Python. So when you install Python on your computer, it's there. You just have to instantiate it or call it. And this is how you activate it. That's how you activate it, by using the import statement up top. And what's funny, if we're thinking about this problem, we have our ticket, right? And we use this ticket, and we use this pretty accurate way to get a Powerball ticket right here. So here's our Powerball ticket. What about the drawing? How do we get the results of the drawing?
What do you mean by that?
Well, I have a ticket, right? I generated a ticket out of thin air. How do I generate a drawing? So the thing I'm comparing the ticket to. And Tom got it. Call the function a second time. That's how I get a drawing. So I have a ticket, and I just call it a second time, and I can just get my drawing. So this is almost not a ticket generator. This is like it's an overall function I can probably reuse for the drawing. And I could probably take the return value from one of these, and I can say my ticket is that, and then drawing is also that. And then I can just compare them, right? So ticket, or my ticket. So let me get rid of this loop count thing. I don't need that anymore. We did a proof of concept there. It worked. We'll never win this way. What do you mean we'll never win this way? Man, look at that. Those numbers never match. Ah, didn't match again. Saved the dollar, or saved $2, right? Oh, I saved another $2. I didn't win. Oh, I got a match though. I have 35 and 35. There. They are. Yep. 1 in 300 million. Yeah, the odds are not in your favor at all, ever. What do you mean, Athena? Does that mean something in the lottery? Like when you match numbers?
Yeah, like if there's, you know how the 35 and the 35 matched, but they weren't in the same place.
Right. It doesn't matter the place, it just matters the number of matches. So, it doesn't matter the order. The calculation basically is, to win the jackpot, whatever millions of dollars, you have to match all 5 and then also match the Powerball. So you have to have the exact match of all those numbers. Which the odds are astronomically low to do that. It looks very simple, like, oh, that's easy. You can just match the numbers, but it's not easy, like, to match, like, at all. And even then, you still probably wouldn't win, because in your lifetime, in 20 years, I think there's like in 20 years, you'll go through like 4,000 drawings. Because it only happens, I think now 3 times a week. It used to be 2 times a week. So, like, and 4,000 into 300 million is still a very tiny number. So, yep, you save your money when you don't play it. But yeah, so this is a good start, right? So I was going to stop here because we've built our ticket generator. We can even almost call this something else, right? We'll keep it as ticket generator for now. And we've built a way to get a tuple, and we can reuse this function for different purposes, right? We can use it for making a ticket, or we can use it for making a drawing. And then we're going to actually get into writing logic to compare the two. So we need to come up with logic to compare the two and give us automated results, not by looking at this visually and seeing where numbers match. I want Python to do it. And then eventually I want to get to the point where I can run this, 1,000,000 times to see how close I can get to winning over 1,000,000 drawings and see how much money I've won based on that. And I can use that to calculate. So there's a whole bunch of options we can do to build this into something more. But just doing this right here went over a lot of our tools that we've learned. We didn't touch some unordered data types. We didn't touch sets. We didn't touch dictionaries. We touched strings. I put a string here in this one. You can also add strings wherever else in your code. We did some comparison operators, some Boolean statements. We did a Boolean statement here to make our while loop run. Another Boolean statement here. This had to evaluate true for this to run. And then we did if else statement. So we've done a lot that combined a lot of the lessons we learned in the past couple weeks to apply just to this function. And we took it step by step. And that's the ticket to development, to coding, to building something. We're going to finish building this, and it's going to be a functioning lottery generator. It'd be kind of cool. So anyway, that's going to be the end of the lesson. I'm going to go ahead and stop recording here, but I'll still be on until 9. So I'm going to go ahead and stop my share, and I'll just stop recording here.